So 2022 paper 2 question 5. Now you wouldn't have been able to do this over the summer, but now that we've covered stats 3, you should be able to do this question no problem, and it should be fresh in your mind as well. So a survey on remote learning was carried out in a random sample of 400 students. So straight away, I know I'm talking about a sample, so N is 400. 135 of the students, now we're talking quantity here, 135 of, we're talking what proportion of the students. So immediately I'm thinking P hat. So 135 out of the 400 said they preferred the remote learning than learning in person. So for parts A, 1, 2, and 3, give all solutions as decimals correct to 4 decimal places. Work out, so question 1, work out the proportion of the sample that preferred remote learning. So I've already done that. We'll just change it to a decimal because that's what they've asked. And to 4 decimal places, P hat is 0.3375. Now, use the margin of error, this, to create a 95% confidence interval for the proportion of the population that preferred remote learning. Now, I would like to think when you guys hear margin of error and you know we're talking about proportion, you guys are going to your cheat sheet and you're thinking, okay, well, I need to use my plus minus 1.96, the square root of P hat 1 minus P hat over N. But they have specifically said use the margin of error 1 over root N. Now, you wouldn't obviously be aware of this, but this is in fact how they do it at ordinary level. The degree of accuracy isn't as good, okay? So maybe that's why they're asking you to do it. So at ordinary level, instead of doing the plus minus 1.96 root of P hat bracket 1 minus P hat over N, they just use 1 over the root of N. It's not as accurate, but it gives you a rough idea. So they're basically saying you're to use this to do your calculation. So we're going to do, so we want to use the margin to do that. Okay, so we're going to do plus or minus our 1 over the root of 400. Now we have our P hat as this 3375. Okay, so now we just need to do that out on our calculator. So the margin of error. So I have 1 over the root of 400. And then I'm going to multiply that by my 0.3375. Now that is giving me, no, sorry, I should have, added or minus that from, not multiplied. Sorry. So, sorry, I take my P hat and instead of doing my plus minus 1.96 root of P hat 1 minus P hat over the amount of the sample, I'm just doing my P hat plus or minus the simplified version. Okay, so I do 0.3375 plus, we'll do the plus part first, 1 over the root of 400. So they've basically asked you to do it as if you were studying ordinary level. And then we're going to change the plus to a minus. Now, maybe this will make sense in the rest of the question in a second. And again, I'm changing that. Okay, so my population should lie between these two figures. Okay, now that is doing, as I said, the kind of not as, sorry, it's just the other way around. Oh my God, what am I doing? Sorry, the smaller one should obviously be on the other side. So one's a little bit down and the other one's a little bit up. Sorry, I'm so used to doing it the higher level way now. I'm confusing myself. Okay, so So what I've done is in part one, I got my p hat. In part two, I've used the simplified version instead of the one that we have been studying. Why? Because they've told me in the question that I have to use that. That's what they've said. Use this to create a confidence interval. So now I've done that. Okay. Part three, use the proportion from A part one to create a 95% confidence interval for this population proportion. Here we go. That is more accurate than the 95% confidence interval based on the margin of error. Okay. So long story short, so this is why they've asked you to do it. They're essentially asking you to redo it now, and they want a more accurate version. Well, this is the one we're normally doing. So our more accurate version is our formula from our cheat sheet. So we have our p hat plus or minus 1.96 root of p hat, 1 minus p hat all over n. And then remember, we have, this should estimate our population for us. So if I do the minus on this side, so I'm just going to write out the formula in full, I think. We do the plus then on the other side. So this is the one on the cheat sheet that we had been using. So I think what they're doing here really is they're getting you to do it in the way that the ordinary level would do it, and then they're getting you to do it the higher level ways, so you can see for yourself that it is more accurate. Okay, so I'm just going to fill that in now. 0.3375, 1 minus 0.3375, all over n, which is 400. Now it's going to be the same on the other side, so I'm going to take a bit of a shortcut. So I'm going to do this side first, 0.3375 minus 1.96 square root. Hit my fraction button, 0.3375, 1 minus 0.3375, all over 400. Now, this is giving me 0.29116. So we'll do 112 because we're told to do to 4 decimal places. Now, I'm not going to delete my screen. Remember, like we did in class, I'm just going to scroll back and change the minus to a plus. That's all I'm going to do. Just change my minus to a plus, 0.3838. Now, this is supposed to be more accurate. So I just want us to have a look at it here as we're doing it. So they're telling us the population should lie between about 29% and about 38%. In the other version, we had between about 28% and about 39%. So can you see in the less accurate version, your actual interval is larger. You're going further down and further up, and it's wider. And the reason it's wider is because it's not as accurate. As soon as you use the more accurate formula, do you see the way I've made this tighter? I've actually tightened up the interval. I've come further up. So I've kind of come up from my 28.75 up to 29.12. And I've come further down. So instead of going up as far as 38.75, we've come down. So the more accurate, the tighter the interval. So in other words, you'll get a better picture of what the population is if you do the better formula. So I'm actually glad we came across that now, because it's good to see that if you use the less accurate formula, which is the ordinary level one, you end up with, you'll still get your answer, but the interval will be wider, which basically means it's not as accurate. Whereas if you use the higher level one, you get a tighter interval, which means it's more accurate. Okay, in 2019, people with a prepay mobile plan spent an average of, okay, so this is a population average. So I'm just actually write this on the side. We haven't looked at the question yet, 20.79. In 2021, some students carried out a survey to see if this had changed. They surveyed 500 people who had a prepaid plan, and that's the mean amount spent. So X hat was 22.16 and the standard deviation was 8.12. Carry out a hypothesis test at a 5% level of significance to see if the charge in the mean monthly spend on mobile phones has, with the prepaid, what has it changed basically on this plan? State the null hypothesis, the alternative hypothesis. Okay, so because we're working on a mean and not on a proportion, we should be on the right-hand side of the cheat sheet. So we start off with the null hypothesis is supposed to be 20.79. The alternative hypothesis is that it's not 20.79 €. So the average bill is not 20.79. Now I have to do my calculations. Well, the calculations I should be doing if I have a mean. So my null hypothesis is this, my alternative hypothesis is that. So all I need to do now really is I need to think about where my actual mean lies in terms of my test statistic. So I'm going to pick out my formula called the test statistic. You can see it on the cheat sheet, but make sure you practice that it is as well on your formula tables. It should be on page, let me see, yeah, page 35. Now, when you fill this in, your Z-score is going to be your N in this case, which was your X bar basically. Sorry, not your N, your X bar, 2216 minus your standard deviation, divided by the standard deviation, and then you're dividing by the root of how many people were in the survey. Now, this is my test statistics, so I'm going to put this into my calculator and see how this comes out. So 8.12 all over the root of 500. Now, this 22, sorry, I must have done something there, 22.16 minus my, I put in, sorry, my mistake, my mu is the original amount, so I should have put in my 20.79. So 20, I put in the standard deviation by accident there in that moment. And then I just divide that by my 8.12 and my root of 500. So that came out to be 3.77. Now, 3.77, when we think about that, we know that that figure is something that lies outside our confidence interval. So remember, the confidence interval should always be between negative 1.96 and positive, the Z-score should be between those. And it's not. So what we can say by conclusion is the Z is in the critical region. In other words, it is outside the confidence interval. It is outside the confidence interval. Therefore, we reject the null hypothesis. And what we're basically saying is it has changed. So the average price of this plan has changed. So sorry, my conclusion is that it is in the critical region, and then that's kind of my reason. So my reason is, yes, it's changed. Why? Because it's outside the confidence interval, so we reject the hypothesis.